Hey guys, welcome to the Intro to Data Science workshop with Python. I'm David Ryan. I'll be the leader for this workshop, also the future event chair for this next year at ACM. So it's an honor. Thank you very much. And yeah, let's get started. So in this workshop, we'll be going over 4 things about data science. First, I'll introduce you what data science is to anyone who really doesn't know what it clearly is about. I'll go over the data science process and why it's an important field. Second thing I'll be going over are just one real-world application of what data scientists can do. There are many real-world applications that data scientists can do to change almost every industry, from healthcare to sports, government to education. Specifically, I'll be talking about the impact of data science in education. And then finally, I'll be going over some important programming languages for performing data science tasks, including Python, and some IDE recommendations that can make reading and analyzing your data a lot more easier. Along with that, I'll also be doing a data science demo on Jupyter Notebooks and explain some of the libraries that professional data scientists will use on a daily basis. So what exactly is data science? Is it a new kind of science? Is it just fancy statistics? What is it really? Well, if you just do a Google search on a definition, data science is about preparation, analysis, visualization, and maintenance of information. It's a cross-disciplinary field which uses scientific methods and processes to draw insights from data. Obviously, this is a Google definition, so it's not going to be that clear. So typically what happens is that you extract large sets of data and analyze it to develop data-driven solutions, which should help you to present your findings to the organization higher-ups, which will then make the best decision based on your findings. So you're pretty much a problem solver instead of just a simple programmer. In short, data science is all about scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. Being a data scientist isn't just one of the top job areas in the world. It's also one of the more highly paid jobs. In Python, we use data analysis methods and machine learning algorithms to gather insights and apply these insights across a broad range of application domains, from business to education, all of that. So when getting into data science, there is a specific process that needs to be followed when performing an EDA or creating just a self-aware AI, for example, like Siri. This is known by many as the data science cycle. The first step is to understand the problem that is given to you, either just a problem you came up with yourself or a problem that the organization has given to you. As data scientists, it's important to ask yourself and the others questions about the data, either it's collected or uncollected, to gain a better understanding. For example, how many of which group is analyzed? Which category should be analyzed? By the time you received all this information, you not only identified all the central objectives, but you also should have be able to identify all the variables needed to be predicted. The second step is data mining. Data mining is a very familiar term, and it's basically where it's all about gathering and collecting data. The difficulty in this step varies because it depends on the situation, on how you collect the necessary data. If all the necessary data is packaged and handed to you, easy, you're done. That's it, you're done with the step. You don't have to worry about looking for data. If the data is in a database, it can be, which is either an organized collection of data or something. You can query that data using SQL or manipulate it using the pandas library, which is, of course, the data frame library in Python. If, however, there's no data at all, you can't find the data, then you're only left with one option, and that is you'll need to scrap it. One of the popular ways to scrap for data, to track user data, for example, is using countless data tracking tools, such as Google Analytics and other kinds of APIs. Then comes the difficult third step in this process, which is basically cleaning the data. This is a time-consuming process because there are various scenarios in which the data set requires cleanup. Data could have many inconsistencies. Some rows can be labeled 0 or 1, others can be labeled no or yes. Even data types can be inconsistent. For example, the zeros can be classified as an int or a string. Another issue in this step is also the presence of missing data. And that's because where there'll be a lot of errors in model creation and training, which is why you need to make sure you deal with all this missing data. There are two ways you can go about fixing this. Either you could ignore the instances which have any missing values, or you can use something called average imputation, which replaces missing values with average of all the other instances. When you have this sweet, clean data set that you have, now it's time to start analyzing it. Data exploration is all about brainstorming things, where you look up patterns and biases within your data. You could analyze a segment of the data using pandas, plot histograms and industry curves to study trends, and create interactive visualizations that tell a story about the data that's given to you. This kind of activity is known as exploratory data analysis, which would be great for a first-time project for any programmers wanting to get into data science. Now, for the next step, once you gain a certain amount of knowledge about the data, you could go through a process called feature engineering. In this process, using domain knowledge to transform raw data into informative features that represent the business problem you're trying to solve. Usually, there are two tasks for them. One is feature selection, the process of cutting down the features that add more complexity and uselessness. The second is feature construction, where you create new features from the ones you already have, or merge multiple features to make them more informative by taking their sum, difference, or product. Once you've created needed features, the next step is predictive modeling, where machine learning is finally being utilized in your data science projects. This is when you train your model in order to evaluate the success of your features. One example is an image classification file, where the common metric is coefficient determination, which gives information about the goodness of fit of a model, mean squared error, absolute, and then absolute average absolute error. Sorry about that. Once it's trained, it is important to evaluate the success of your model, either using train test split or k-fold cross-validation, which is the most common accuracy measure. Final step of this data science cycle is data visualization. Now, if you might remember from the last slide, I talked about how you could mess around with different data visualizations in order to see some depictions of data. You're basically doing the same thing, except with the ultimate goal of communicating the data in a simple yet effective and visually pleasing way to your organization higher-ups or just some newer people who are new to this. I'm not going to go deep into it right now, but some of the best ways of doing visualizations are using Python libraries like matplotlib and Seaborn, or using JavaScript to create some majestic data visualizations. And all this and plots and all these kinds of plots and stuff will need to be presented in some sort of Google slide or Microsoft presentation, something like that. Data visualization is the coolest part because it's kind of like art, except rather than using paintbrushes or just scribbling Microsoft Paint, we're using actual data to create art. And that's crazy. So we want to go to the most important question, which is why is data so important? That is because data is the new oil. Corporations are swallowing up so much data. There's like a huge, like Google takes in like more data than we could possibly imagine. Every single company takes up a lot more data. And there's a huge shortage of data scientists who can synthesize huge amounts of information from multiple sources, already known as big data, driving the insights, convert data into actual information, then articulate their findings. Google obviously processes over 20 petabytes of data daily. That's a lot of data. And so that we talk about the concept of data science and why it's such a big deal, we're going to go over some of the applications that data science can have in the real world. One of which is data science in education. With schools, colleges, and universities having an enormous amount of student data, such as academic records, results, grades, etc., to handle. And analysis of this data can help educators find advanced ways to enhance student learning. One of these use cases is to improve adaptive learning, where you could supply a singular yet personalized experience for each and every user through customized content, real-time feedback, and resources. With big data itself, teachers can discover the abilities of students and use optimal teaching techniques according to them. Another use case is to improve a student's performance, where you can analyze a student's performance in schools to make changes in a way that helps students solve their problems. For example, let's say that Vince is a poor student day by day. Well, guess what? Big data analysis in education can help teachers identify the main reason and help Vince overcome problems in school. Pretty cool, am I right? So here's the thing. What is the programming language for data science? Hint, hint, it's actually it's actually the whole title of this workshop, and it's Python. Python is a powerful object-oriented language. All you guys heard, it's very dynamic, it's easy to learn, read, and understand. It has very simple syntax and declaration. It has faster development processing, and this makes it best for machine learning, deep learning, and AI. Perfect, and it's perfectly suited for data manipulation and visualization. There's a whole wide range of data science libraries, from NumPy to Matplotlib to scikit-learn, and even TensorFlow. And we'll go over some of these libraries sooner in the demo. Now, of course, it's not obviously limited to Python. There are also other languages as well that I kind of dislike, but I still recognize. One of them is R. For any of you guys that are taking any statistics classes, especially Stats 107, R is an OOP, or known as object-oriented programming language, built by statisticians. It primarily handles statistic analysis and graphics, and it offers efficient handling of data and visual analysis tools such as clustering and time series analysis, and does provide options for plotting, like ggplot2. And to this day, R still includes and has a huge active community of contributors. Now, for this language, it's kind of like it's the second most language you'll also be using. It's actually the best tool that you'll need behind Python. And it's SQL. SQL means structured query language. It's a standard language for storing, manipulating, and retrieving data in relational databases. It allows you to create new databases and allows you to create new tables within these existing databases. To manage a relational database, you'll need to use a relational database management system. Now, there are all sorts of different examples, which I'll go over in the next slide. So now now you guys heard all these programs, all that. I think it's a good idea to tell you which ones I recommend for doing some data science stuff. If you like to use Python for all things data science, including machine learning, the best IDE to use is Jupyter Notebooks. For anyone who's familiar with Jupyter Labs, Jupyter Notebooks is pretty much the same thing, except you don't need the internet to access your notebooks. It's a web-based user interface that can be used to combine software code, computational output, and explanatory text into one single document. For data scientists, it's the perfect tool for doing data exploration and visualization. Now, it is also worth mentioning that JetBrains, the company behind Intelligent PyCharm, does offer Jupyter Notebook support for PyCharm. As I'll show you right here, they do offer you support for Jupyter Notebooks and all that. They also released a new IDE back then called DataSpell, which is basically a really good application for data scientist purpose. So if you want to do exclusive data science stuff, this is the best IDE for you as well. Now, if you like to only do statistical data analysis or you're just a statistician, then the popular IDE out there is RStudio. It includes a console, syntax highlight editor, all that kind of good stuff. You guys are probably familiar about it with Stat 107 or even Stat 10 or Stat 11. So I'm not going to go that deep into it, but just know that all the R libraries and tools have all the things you need to do some lit data analysis. Now for SQL, it can vary because it depends on which relational database management system you could use. The SQL language can change a little bit when looking at the different RDBMS systems, which is why it's okay to use any system that you're comfortable with. Some notable ones are the Oracle database, Microsoft SQL Server, or even MySQL, and there's still lots more, so feel free to explore. Okay, cool, so thanks, now it's 5:20. It's time for a fun demo. We're gonna be doing a LendingClub loan prediction demo. We will be using the language Python. It is the recommended IDE is Jupyter Notebooks. If you guys can feel free to use Dataspell or PyCharm, or just do the method I'm doing and just download Jupyter Notebooks alone. You can also download Anaconda, which is basically like a package that contains all the data science applications that you need. And if you want to access this demo, it's on the GitHub page. So I'll go ahead and copy this here into the chat real quick. All right, here you go. I put it in here. So let's just say, so if you want to install Jupyter Notebook straight into like your computer, all you can do is that you can go to the terminal, type in pip install notebooks. Yeah, notebook. And it'll download you the entire library into it. And if you want to activate it, you can just run this simple command, Jupyter Notebooks. I'm sorry, Jupyter Notebook. There you go. So yeah, this here is Jupyter Notebook. And basically, if you guys have already downloaded the repo by now, you should be able to have it in your GitHub folder, which is right here. And you're given two data files. You have LendingClub data.csv and LendingClub info.csv. Now, info just basically shows all the descriptions, all different features in your data set. And then LendingClub data is the actual data set. So don't try to confuse the two. So we'll be loading this notebook. It does take some time. And while we're at it, we can talk about some of the libraries that you'll be required to install. So the 6 main libraries that you need to install for this specific project, for the specific demo, sorry about that, is NumPy, Pandas, Matplotlib, Seaborn, sklearn, and then TensorFlow. If you're using Anaconda 3, then you can just do conda install NumPy, conda install Pandas, etc. If it's other IDEs, you can do pip install NumPy, pip install Pandas, and all of that. So I'm just going to go ahead and install all of these. Actually, you know what? I don't have to, because like I'm kind of, Jupyter kind of locks me out of the command. So yeah, I'll basically here, I'll copy all this. I'll copy all this and put it in the chat for you guys to see. Let's see. Very cool. All right, so now that I pasted it to you, let's get started. So obviously the data we'll be using is a subset of the LendingClub dataset obtained from Kaggle, which is right here in this link. So if you guys want to go to the link for where I got the data from, you can click here. Now for any of you guys who don't know what LendingClub is a US peer-to-peer lending company headquartered in San Francisco, California. Obviously, so basically what they're known for is loan trading on the secondary market. And our goal right now is, given the historical data on our loans, Given enough from the information on whether or not the borrower defaulted, or known as charge off, can we build a model that can predict whether or not the borrower will pay back their loan? So basically, like, they're asking us, like, can we predict whether or not this borrower will pay back their loan for which money we gave back to them? This way, in the future, when we get a new potential customer, we can assess whether or not they're likely to pay back the loan. Keep in mind classification metrics when evaluating the performance of your method. So right here, we have like, so here's all the information about your particular data set right over here. So you got things like loan amount, term, interest rate, installment, all sorts of stuff. Pretty cool. So now, what we're going to do is that we're just going to put some starter code in here. So the first thing we're going to import here is pandas. Now, we'll get to pandas in a bit, but for now, I have to just type in import pandas as PD, have a run here. And what to do, make sure you create a data frame called data info, which basically reads the data from this file here, LendingClub info.csv. Well, and make sure you set the index column to loan stat new, which is right here. Now we see that it basically read it successfully. Now, in order to test this, we have to print out like a sort of description from this data. So we'll do data info dot location, and pretty much we'll have it read like we're going to a matrix. Data util, and then description. Let's see if we can get the description for this. Oh, okay, good. So pretty much revolving line utilization rate is basically the amount of credit the borrower is using relative to all available revolving credit. Okay, good. So we got the description for that. So, I mean, it's gonna be pretty difficult to type this code all over again. So we're just gonna create a simple function called feature info. And what this will do is that it'll take in the name as a parameter, and it will pretty much simply print it. So yeah, very simple. Now you don't have to like type in this code over again. You can just call feature info. Pretty easy. So let's actually test this out. Feature info. And then let's do issue. Actually, let's just do zip code. Oh, my bad. Okay. It's called zip code. Let me just double check. It's zip code with the underscore. All right, cool. So this function works. Now we're just going to load all the other data and all the other imports. So before we load these in, I think it's a good idea to go over what these libraries will be using. So for the first one library we'll be using is NumPy, which is pretty much a linear algebra library for Python. So if you guys took Math 31, you guys should be familiar with what linear algebra is. In fact, taking Math 31, it's a very good reason there's actually a very good reason for taking Math 31 if you're in data science. So NumPy has functions for working in domain of linear algebra, arrays, and matrices. So this basically So basically has like mask arrays and matrices. Now, I bet the question you guys are asking is, why use NumPy arrays? Why not Python lists? Python lists are so cool. No, NumPy provides an array object that is basically 50 times faster than traditional Python lists, due to the fact that like NumPy arrays are just stored at one continuous place in memory, unlike lists. Let me repeat, is all stored in one continuous place in memory. That is why it's fast. So if you want to import it, you just do import NumPy as NP. So we're just going to do that real quick. Now, the second library we'll be going over is pandas. Now, we talked about past where I mentioned data frames and all of that. So what exactly is pandas? Pandas is basically a data manipulation and analysis library that provides fast and flexible data structures designed to make working with relational or relatable data both easy and intuitive. Panda does a really good job with handling missing data and allows for creation of new columns and a lot more. The two data structures you'll be facing the most is a series data structure, which is a one-dimensional label array capable of holding any kind of data type. So it can be integer or float or a string, anything like that. And then you have a data frame, which is a two-dimensional label data structure with columns of potential different types. It's pretty much a matrix, and it acts as like an Excel spreadsheet. So if you want to import that, we just do import pandas as PD. And now we'll go to the next library, which is very necessary. It is called matplotlib. Now, matplotlib is what I consider to be the granddaddy library of data visualization in Python. Now, just a curious question. How many of you guys are familiar with Matplotlib? Nope, no one's familiar with Matplotlib? Cool, okay. Okay, well, in that case, as you know, MATLAB is pretty much similar to, Matplotlib is pretty much similar to MATLAB, but it's built for Python as a NumPy extension. What makes Matplotlib great is that it is easy to get started for simple plots and has support for custom labels, which allows for greater control and higher quality output. So you get nice looking plots like these over here. Now, of course, matplotlib isn't enough. In fact, I don't prefer using all the matplotlib functions. So one of the other data visualization libraries that I use is Seaborn, which is a Python data viz library that's basically built on top of matplotlib. It provides high-level interface for drawing very attractive, informative graphs, like this one over here, from distribution plots to regression plots. Heck, you could even create a pair plot like this one here on this slide with all the different visual graphs. So you could definitely see me using Seaborn a lot in this demo. And of course, if we're going to import matplotlib and Seaborn, we just do import matplotlib as pyplots. Sorry, no, matplotlib.pyplot as plt, and then import Seaborn as SNS. So keep in mind, we are going to use Seaborn. I just imported matplotlib here because we need matplotlib to operate Seaborn. Now, to make producing graphs much easier, you will need this command here, matplotlib inline. And the reason that you guys need this is, well, I'll show you guys in a bit, but it's really cool. Basically, it generates your plots on the spot without having to do like plt.show each time. So it's very useful. So now that we imported our libraries, we'll be basically reading our actual data. So PDF which means data frame is equal to pd.read CSV. And then you'll need to basically read this data file right here. So we'll give it time for, oh, it's already done, cool. So let's gather some more information about this data set. So we'll do data df.info. Okay, cool. So this gives you all information about what kind of type is this feature. So subgrade is an object, annual income is a float. So pretty good stuff. So now that we've basically loaded our data in, and now that we import our libraries, we can get started with some exported data analysis. Now, the point of this is to get an understanding for which variables are important and which are not, use some summary statistics, and then visualize the data set. So our first task will be to predict loan analysis, loan status. So we'll be creating a count plot first. So in order to create a count plot, you just simply do sns.countplot. And then you set the X to loan status. And you definitely want to clarify that the data you'll be using is the data frame you have set over here. Let's run that, and then voila. You just created your first plot, guys. Congrats. Congrats. Okay. Anyways, you can fully see here that like all the information, like how many have fully paid their loans and how many have been charged off their loans. Now we're going to be creating a histogram of the loan amount column. So I think I'm just going to quickly show you guys how you can use just Matplotlib itself to make a plot. So first thing you'll set the size of the plot to 12 by 4. And then we'll be basically setting the disk plot. Okay, so cool. So now we have the feature that we want. It's like we can set KDE to false. And then bins to 40. So basically what bins is that there'll be 40 bins in this histogram. So let's run it, and then here you go. Oh, wow, okay. It looks very, very like scrunched together. So let's fix that. You can simply just do plt dot slim. Let's just do 0 to 40,000. Yeah, that looks good. Okay. Yeah, actually, I'm not so sure why it's like still like that. All right, well, that's fine. I'm not gonna stress about it. Anyways, so let's just explore the correlation between the continuous feature variables. Let's first of all calculate the correlation of all the continuous numeric variables using the .core method. So we can just do df.core. What this would do is that it'll show you the correlation between one feature and another. So we can see here that there is about a 17% correlation between loan amount and then interest rate. And that there's a correlation between loan amount and then installment. These are very important as these will help you make further insights down the road. Now let's get to making a heat map. So if you guys don't know what a heat map really is, I think I'll show you right now. First off, if you want to create a heat map, you just do this sns.heatmap and do df.correlation. That's important here. You need to basically show the correlation of your data, not just the data itself, the correlation of your data. You definitely want to get your annotations. So you need to set annotation to true. And then you could definitely set the style of your map, which is actually my favorite part. So I'm going to set the style to, let's say, this one. This one has a really cool color scheme and I like it so much. So let's run it. There you go. Now it does look very tiny. So let me see if I can fix this. I'm going to set the size to 12 by 7. There you go. Nice. Okay. So yeah, you can definitely see it's a much bigger heat map now. So this basically visualizes to you like the correlation between like two variables. So you can see like all the ones that have like the highest correlation are yellow. The ones with the lowest correlation are very, very dark blue or purple. Now the next task will be to basically like observe this and see which one has perfect correlation. And we can see here that one that has like near perfect correlation is the loan amount and the installment. So what we're going to do next is, well, first we're gonna have to grab some info about what installment is because we have no idea. That's the fun thing about being a data scientist. You just explore stuff. Very cool. Okay. So you can see here the monthly payment owed by the borrower. So basically that's the definition of it. That's pretty cool. Now let's go over what the future loan amount is. All right, cool. So loan amount is basically the amount of loan applied for by the borrower. Okay, that's pretty cool. So I think I want to get a pretty good idea about how well correlated the two variables are. So I think I'm going to create a count plot first. So not a count plot, a scatter plot. So to create a scatter plot, you just do sns.scatterplot. You set the x to installment. Okay. They set the y to loan amounts. And you obviously want to clarify that you're getting your data from this data frame, df. So run that, and there you go. You basically produced your first scatter plot. And you can definitely see here why there's a very perfect correlation. Now, does the relationship make sense to you? Yeah, I think so. But I do believe there is some duplicate information there as well. So when it comes to duplicate information, we'll fix that later on. Now let's see now of course we should make a box plot to show the relationship between loan status and loan amount. So in order to do that, you just need to run sns.boxplot. Set your x to loan status. And y to loan amount. And then basically you get your two box plots here. Now, of course, that information may not seem enough. Of course, the sizes of the box plot look about the same, but we do need like a detailed summary of it. So if you ever want a detailed summary, we'll need to use the described function. So of course, you'll need to do a group plot. You need to do df.groupby. What groupby does that it pairs the two features together. So you pretty much have to do let's see this, and then loan amount. My bad, I shouldn't have these brackets here. And then you should be able to run the describe function here. And then voila. So it gives us the mean, the standard deviation, the first quantile, the third quantile, and then the max and min. If you got to our statistics, you guys should know about the 5-number summary. This is basically kind of it, except this is pretty much how you code it. So yeah. So now that we explored this, let's also explore, well, we could also explore all the other attributes, but it's pretty much just going to take lots of time. So I'm just going to skip to pre-processing and then just focus on removing any missing data. So the main question that we have here is, how are we supposed to find missing data? Well, first of all, I think it's a good idea to understand how big this data frame is. So to do that, you just need to run like len.df. And we can see here that the size of this is almost at around 400,000. Pretty cool. Now we want to see how can we find out like which columns have missing data. To do that, you need to use the isNull function. So you need to do df.isNull. And what it'll do is that it'll check to see like which variables are null, which have some missing data. And then make sure you also add the sum function to get the sum of all the missing number of data points. And so you can see here that emp underscore title and emp underscore length has missing data. Title has missing data. Revol underscore util has missing data. And then mortgage account also has missing data. So we have about 1, 2, 3, 4, 5, 6 features or columns, or actually not columns, rows that have missing data. So I think what we want to do is that we want to convert this series to be in terms of percentage of the total data frame. So it's just going to be quick. So we're just going to run this here and just show you like how much of percentage of the data is just filled with missing data. So 9.5% of the missing data. There's like 9.5% of missing data in mortgage account. So now we've figured out like, okay, how much missing data is in here. We can then examine like, okay, what's an emp underscore title and emp underscore length. So in order to do that, I think we should get a description for one of these. So I'm just going to do this. So we can see here that emp title is pretty much the job title supplied by the borrower when applying for the loan. And then emp underscore length, it's basically employment length in years. Its possible values are between 0 and 10, which means less than 1 year, and 10 means 10 or more years. Okay, so now we just want to, so now we know the information for this. Now we need to see like how many unique employment job titles are there. So in order to do that, you do df emp underscore title dot n unique. And we can see here that there are about nearly 100,070 unique job titles. And then like we can just, now let's just see like the value counts for these. And what value counts does is that it tells you what kinds of how many amount of these jobs are there. So we can see like about 4,300 of these loans are from teachers, and about nearly like 18,000, 1,830 are from supervisors. And there's about like one from an health source specialist and one from Kennedy Club Fitness. I have no idea where that is, but cool. Realistically, there are way too many unique job titles here. So let's convert this into kind of like a dummy variable. So I think let's just remove the emp underscore title column. To do that, we just do df gets df dot drop, then emp underscore title. Make sure you set access to 1. If you don't do that, data is going to get screwed up entirely. So please, for the love of God, do access gets 1. Because it'll just delete the row instead of the column. So yeah. So now it's already deleted. Now all I have to do is create a count plot for this specific feature column. Now, of course, first challenge, we should set the order for this. Now, in Python, there is a sorted function, so we'll use sorted. And we can just do df gets and underscore length title. Actually, these should be brackets, not parentheses. Okay. And then drop. Now this should be able to run. Oh, okay. Oh, wait, never mind. I'm supposed to drop the length, not the title. Oops, my bad. Okay, there you go. It's all resolved. Oof, thank God. Very cool. So now that we sorted all of it, now all we have to do is pretty much send the length order from less than 1 year to more than 10 years. Or once we do that, we can create a count plot for this. So let's do SNS dot count plot. X gets emp underscore length. Make sure you set the data to df, and make sure you set the order based on what you said right here in empirical length order. So there you go. Now we could make this bigger, so I'm just going to adjust the figure size, the plot figure size to 12 by 4, and I should be able to make it bigger. Yeah, there you go, made it bigger. Cool. Okay, so now we have that. Next thing we're going to do is plot out the count plot with the hue separating fully paid and versus chart off. So I'm not going to waste time coding all this by hand, so I'm just going to copy and paste it. And what this will show is that a huge amount of these loans have been paid off, about 10 plus years. And there's about the 1% that's paid off is also more than 10 years. So that's very insightful information. I'm not going to go over this section because it's not really necessary. If you want to, you can do this yourself, but you don't have to. So yeah, I'm just going to quickly move on from that. So next part is So next off is that charge-off rates are extremely similar across all employment lengths. So go ahead and drop the empirical length column. Okay, so to do that, you can just do df gets df dot drop empirical length. Oh, and make sure you set access to 1. Yeah, sometimes I keep forgetting to do this, and it's just bad. You don't want to delete like entire row. You just want to delete the column itself. Okay, cool. So now it's basically deleted it. Now that we've deleted, let's revisit data frame and see what else is missing. What else has missing data? So we do df.is null. So just run this command again. And then we can see here that title is left. Revo underscore util is back, is left. Mortgage account is left. And then public recent bankruptcies is also left with missing data. So review the top column versus the purpose column. Is this repeated information? Well, let's see, guys. Let's observe it. df.perp. Get the purpose. And see whether or not if this is necessary. Oh, I spelled purpose wrong. Oh my god. So let's do the first 5. I want the first 10 of this. Let's see. Okay. So we got vacation, debt consolidation, credit card. Yeah, sadly. Okay. Now let's see the title one. So we can just copy this one. And then we can just view the title. Okay, so it's just repeating information. So let's just drop the column file then. So just to make this easy for myself, I'm just going to copy this, put this here, and then just drop title. And boom, title's gone. Oof, crazy. Okay. So the next part is we want to find out what the mortgage account feature represents. So yeah, I might be able to, yeah. Anyways, oh, by the way, it's 5:57, so this might go overboard. This might go over the 6 p.m. So if you guys want to leave, you guys can do that. I'm going to record this, and it'll get posted on YouTube later. So yeah, if you guys want to leave, you guys can leave. But if you guys want to stay and watch it, you guys can totally do that. So yeah, totally fine. So yeah. So let's find out. So of course, back to what we're working on. We want to find out what the mortgage account feature represents. So we're just going to do this and observe what and see what information mortgage account gives. And basically feature. Okay, so basically it's the number of mortgage accounts. Okay. I'm probably not going to. Okay, so definitely we want to get the value counts for these. So let's check these out. Okay, so there's a lot that are 0 and there's only one that's 34. Okay, so there are many ways we could deal with this missing data. We could build a small to fill it, such as a linear model, or we could just fill it based off the mean of other columns. I'm not going to go very deep into this, so I'm just going to copy and paste this code and just share you guys what it is. So what we're doing is that we're basically going to first sort all the mortgage accounts, all the values for these. So the lowest is like interest rate and then the highest is mortgage account. And the next thing we're going to do is that looks like total count future correlated with the mortgage account future, which makes sense. Let's try to fill this with the fill and a function approach. We'll group the data frame by the total count and then calculate the mean value for the mortgage account per total account entry. So to get the result below, we just need to basically run this command here. Very cool. And this part is also very challenging, so I'm not going to spend as much time. So I'm just going to copy and paste all of this. Because I want to quickly get to the part where we basically like create the model and then test it. So yeah. Okay. So next part, we can just remove these rows over here. So we do just df gets df dot drop and a, and then df dot is null function dot sum. Now let's see what else we have left. Okay. So yeah, great. We just dealt with all the missing data. Cool. So the next part, we're gonna list all the columns that are currently non-numeric. We just need to deal with all the string values, do all the categorical ones. Okay. And now we want to convert the term feature into either a 36 or 60 integer numeric data type using the dot apply or dot map method. So you guys should be familiar with maps because I'll gone over them in CS10C. If not, then it's okay. So now we already know what grade is part of subgrade, so we can just drop the grade feature. So df gets df dot drop grade axis gets 1. And now we drop the grade feature. Then we can convert the subgrade into dummy variables. Then we can calculate these new columns to the original data frame. So the way we do that is we just create a data frame called subgrade dummies, very funny name, which pretty much gets all the subgrades. Converts them all to dummy variables. And then once we do that, we can concatenate this into the actual data frame. Okay, cool. So now we've done that. So we now basically like put the subgrade into, so pretty much we converted subgrade into dummy variables and then we added it into our actual data frame. So now we're going to convert these columns, verification status, application type, initial list status, and then purpose into dummy variables as well. So this part's going to get very long. It's going to be a lot of code here. But if you guys want to view this code, I also created a solution notebook on my GitHub page. So if you guys want to, you guys can run it and you can see how it goes. once you do that, we're going to convert these dummy variables, and then we're going to end up with just 4 categories, just mortgage, rent, own, and other. Then we concatenate these, and then we add them to the original data frame. So in other words, we're pretty much creating new features. Pretty cool. Now we're going to create a new feature that's going to be called zip code. So to do that, we just take the zip. To do that, we're just going to take the information from the address column. And we're going to have a lambda function that pretty much just gets the zip code, and we create a new zip code feature. Now we can also make the zip code one. Now we can also make the zip code column into a dummy variable using pandas. So I'm just going to do the dummies gets pt.getDummies. You grab the data frame of the zip code, you then drop it, and then you can concatenate it into the data frame. And now we're pretty much just doing the same thing for issue underscore d. So we're just dropping that too. This would be data leakage, obviously. That's the reason why we need to get rid of this. So now we drop the issue underscore d feature. And now what we're going to do next is that IDEs underscore CR underscore line appears to be a historical timestamp feature. So we're just going to extract the year from this feature using the .apply function, and then convert it into a numeric feature. And then you set this new data to a feature column called earliest underscore CR underscore year, and then you drop that feature. Okay, so now that we dropped it, now we can totally get to making training sets and testing sets. And in order to do that, we need to utilize the sklearn library. So I'm just going to quickly go over what sklearn is. So sklearn is pretty much, of course, before we split our data into train sets, it's good to know what scikit-learn is. Scikit-learn is a Python machine learning library that has a range of supervised models, but it can do things to help like split your data or normalize your data as well. Some popular groups of models include clustering, cross-validation, feature selection, and extortion, and dimensionality reduction. I'm not going to go super in-depth into all these models because it's a lot, and I want to finish this real quick, but I'll put the diagram here if you want to see the various models, and I'll post these slides later on if you want to see them. And this is also available online as well if you want to check it out. In the meantime, we'll move on towards splitting the data and normalizing it. So to import train test split from sklearn, we're pretty much going to do, from sklearn dot model selection. I'm just going to import train test split. Cool. So now that we've imported it, oh my god, syntax error. Oof, okay, good. So now that we've imported it, our next task is to just drop the loan status column we created earlier. So because it's already a duplicate of the loan repaid columns, that's why we don't really need the loan status column. So just dropping that. And now once we do that, we're basically just going to set our x and y variables. So our x will contain the loan repaid column. X will contain the let me fix this real quick because I don't want to screw this up. Okay, well, there seems to be an issue. That's not good. Yeah, okay. Yeah, I don't know what's going on. I'm probably not gonna spend all this time looking at this error. Yeah, that's a huge bummer. Yeah, I'll wrap it up in 2 minutes. But pretty much that's pretty much a demo. That's pretty much the demo that I've got to so far. There is still one library I want to go over, and it's called TensorFlow. I'm just going to be really quick with this, but basically this one's the big one. It's an open source library for deep learning and AI. It has like a huge range of tasks, but it's probably focused on training deep neural networks. Now, if anyone can guess who created TensorFlow, it's Google. They created TensorFlow. I'm not going to go over odd differentiation, but the main ones you do need to know are losses, metrics, TF.NN, and then optimizers. I won't go in deep into it, but you can definitely read up the documentation online. You want to check it out. Now, if you want to know what a neural network is, of course, I mean, basically a neural network is like, it's a collection of neurons that take input and in conjunction with information from other nodes, it can develop output without programmed rules. Essentially, it solves problems to trial and error. So how it works is that you have an input layer, a hidden layer, and an output layer. Input layer is composed of input neurons that brings in the initial data. The hidden layers acts like the secret sauce. They allow you to model complex data thanks to neurons. And then output layer is just like, it's just an artificial neural network is like the cluster of neurons that produces the given outputs for the program. So of course, I mean, if you look at the very end of this notebook, it does show you how it's going to turn out. So let me just scroll here. So you can definitely see here that like this is how you create the model. This is how you train it. That's how you fit it, and that's how you basically like check. That's how you validate your model. So I mean, sadly, like we couldn't even finish the entire demo. Kind of a bummer, but it's okay. If you guys did, in fact, go ahead and finish it, I mean, congrats, you've done your first data science project. Now, of course, for anyone that wants documentation for Python libraries we use, as well as insight onto the data science cycle and new information about neural networks, it's right here. If you're interested in learning more about data science, there's also this cool data science course that I recommend. It's called Machine Learning Udemy course by Jose Portilla. He's very good at teaching this stuff. I used his site before. He's really good at teaching data science. So it's really good it's a really great course for anyone who's interested in learning data science as a side hobby. And yeah, thank you. It's a bummer we couldn't finish the entire demo. But yeah, if you guys got any questions, let me know. And then yeah, thank you.